Hello, my name is Doug Raybuck, and I am a new PhD student here at the University of Tennessee in the Department of Forestry, Wildlife, and Fisheries. And I'm here today to talk about a project I was recently involved in. It was part of my master's project, and it dealt with radio tracking cerulean warblers to find out about the post-fledging period. And part of that was looking at habitat use and habitat selection, and that's going to be the focus of this webinar talk today. I'm going to talk about the statistical analysis that I used and a possible alternative that I could have used and compare those results. So, some background about cerulean warblers and our project. This species has been declining at about 3% per year over the past half decade, making it a species of conservation concern. Looking at ways to reduce these trends, whether that be conserving or enhancing habitat on the breeding grounds or the wintering grounds or both. They have a complicated life history, and I'll get into some more of that here in a minute. A lot of research has been done over the past 10 years, but most of that is focused on nesting ecology. And very little to nothing is known about the post-fledging period, which may be just as important because other studies have shown predation rates during this period between leaving the nest and initiation of migration as being as high or higher as during the nesting period, especially during the first week or so post-fledging. But these other studies have been highly variable. They've been understory species just because they're easier to study. This is basically the first canopy species that's been looked at. But reports have been variable. Survival's been 23 to 80%, 87% actually. And a lot of the studies are finding that fledglings are using different habitat than adults do for nesting. And fledglings and the parents that are still feeding them during this dependent period, the first 3 or 4 weeks of the post-fledging period, they're actually usually divided. The broods are divided. The male will take half, the female will take half, and they'll continue to feed the young ones. So little is known about this period for many species, especially for canopy species, including the cerulean warbler. There you have an evil little chipmunk. A lot of people think they may be cute and cuddly, but they have black souls, and they'll eat a baby bird at any chance they get to sink their teeth into them. We did identify it as our most common predator at our sites anyway. So cerulean warbler nesting habitat, we know that they like steep slopes, usually northeast facing slopes. They like big trees, they like canopy gaps, complex forest structure. Sometimes when you have a homogeneous forest with closed canopy, sometimes reducing basal area and opening up some of that canopy can help attract ceruleans for nesting purposes, but we really don't know how that affects fledglings and whether or not they continue to use this sort of habitat. So there is a document that's called the Cerulean Warbler Forest Management Guidelines or something along those lines, and we wanted to know should those guidelines be adapted to include post-fledging habitat if we do find out that is different than nesting habitat. So our goals were to test for habitat selection within this matrix of forest management habitat types, and we did this for the entire tracking period. So that's 0 to 36 days. Most of our depredations occurred during the first few days, so our sample size did decrease over time. And we looked at age class specific habitat selection. So one may expect that as fledglings become more mobile, that they may change their selection strategies, and maybe cover would become less important and food availability more important. So we kind of broke it down into several age classes. And then we looked at habitat used by fledglings strictly compared with adult nesting habitat. So number one was habitat selection, so that's used versus available habitat. Number two is just comparing used versus nests habitat at the nest that these fledglings came from. And I'll get into this, never mind. So here's our study sites. This was in western Pennsylvania on the Allegheny Plateau. This is within and adjacent to the Allegheny National Forest. You can see it's got a fairly rugged topography. There's a lot of stream valleys and river valleys, and mostly contiguous forests across the landscape. Within each of these sites, there were forest management stands, here shaded in yellow. So these had a lot of cerulean warblers. It was your shelterwood type harvests with a reduced basal area. And then in the purple here is unharvested areas with a lot of ceruleans. There were a lot of natural canopy gaps along that steep river slope, and we focused with our efforts kind of in areas where these fledglings had choices, and they did move several kilometers, a lot of them within the tracking period. It's kind of hard to keep track of them all, even with telemetry. But here's a brief explanation of how we capture these birds. We found about 40 nests, and some of them failed, some of them fledged. We did our best to estimate fledge dates by monitoring every 1 to 3 days. And then when the fledge date approached, we had somebody camped out and ready to capture these fledglings. And here they are. We had to be sort of opportunistic about this, unfortunately, because we weren't able to capture all the birds that we tried to capture. A lot of them stayed out of our reach, which is going to probably bias our survival study. But as for habitat selection, the birds that we tagged, they were generally back in the canopy, and mobility didn't seem to be affected. And other studies have shown negligible or little effect of mobility using the figure 8 harnesses that we used. So these tracking devices lasted about 30 days, and we were able to obtain daily locations after releasing them as close as possible to where we captured them. And once we recorded these locations, we marked them for later habitat analysis. And here are the 9 variables that we looked at that we felt best characterized the vertical and horizontal structure of the forest. All of these were measured in the field except distance to water body, which was measured in Google Earth. And by water body, I mean second order stream or greater, so we're talking riparian areas. Here are the age classes: 0 to 2 days, 3 to 6 days after fledgling, 7 to 12, 13 to 20, 21 plus. So again, we broke our analysis down to see if selection changed. And you can see here TV7 is the nest, and first few days they spent very close to the nest and barely moved, and eventually dispersed. So here's an example of how we chose our available points. So we had paired available points. This was a paired analysis, the habitat selection part. So we considered available habitat to be the area within a radius of the maximum distance the bird had moved at that age class. So there at U3, that was the furthest we had detected a bird from the nest during those 3 days. So we assumed that the bird could have been anywhere in that circle. So we randomly selected 3 points as available points. So our data analysis, we constructed general linear mixed models, and with the response being use or availability, so it's a binary response, logistic response. And we compare the 85% confidence interval of the slope of the beta estimates for each of these variables that were identified in the top models to look at directionality of selection. And if that 85% confidence interval overlaps 0, we considered it to be unimportant or uninformative. This Arnold citation here, I'll show you the paper, but they imply that an 85% confidence interval is more compatible with AIC information theoretics than a 95% confidence interval would be. We may end up reporting both, but I looked at it, and there's really not much difference in the interpretation whether you use 85% or 95% confidence intervals. But here's the paper if you want to read it. Let's see. So I'll show you an example of our modeling here in a minute, which we did in R. For habitat use, we employed a similar method, only we just, instead of used versus available, we just compared the nest versus fledgling locations. And we didn't compare as many models in this habitat use analysis. We just looked at univariate models, which simplifies things, and that's what I'm going to compare that with the alternative analysis that we could have used, which could have been Mann-Whitney tests, which is a non-parametric method. Our variables are habitat variables. A lot of them were not normally distributed, and that's even after transformation attempts. So we decided to go with these Mann-Whitney tests. They don't compare a mean, they compare a distribution, the distributions. So we would compare, for example, average DBH, we would compare between used locations and nest locations and see if those were different. So our results, let me just go briefly mention the habitat selection results. And so we had one top overall model for the entire tracking period, which was nice to only have one top model. Fledgling selected for increased mid-story, decreased basal area, and decreased distance to water. The increased mid-story, really, we expected more mid-story cover implies that there would be more protection from predators, most likely, and distance to water, they tended to move toward the riparian areas, which a lot of birds tend to do during dispersal. We did discover evidence for age class specific habitat selection. And I just realized I haven't been using the slide presentation mode. Let me do that. So yeah, during the first few days, fledglings used areas with lower basal area than available, but then they kind of changed it up as they became a little more mobile and moved out of the harvests and into more dense forests, and then where there's more protection from predators. But then at later age classes, it seemed like maybe they were using more habitat that was closer to adult habitat. Sapling cover, similar trends, similarly different between age classes. But comparisons between habitat used by fledglings in the nest, we had this trend of decreasing average DBH as the fledglings aged. So they were using areas with smaller trees than nesting habitat. And they were using areas with more mid-story cover. So here's some of the nesting habitat where fledglings in this area may have moved out of it into areas with more dense mid-story cover, such as this. But they also use some regenerating clear cuts, some younger ones, and then some 25-year-old or so regenerating clear cuts in areas with really dense areas. Sunlight, road disturbances allow a lot more sunlight to increase mid-story, and so do deer exclusion fences. I've gotten ahead of myself. I apologize for that, but well, thank you, collaborators. I'm going to just spend a few minutes to go over my alternative analysis and compare it with, let's see. Oh, Pirates are winning 10-1. That's surprising. I thought I was organized. So here we go. Here was our a table. Let me interpret it a little bit. Let's just, for brevity's sake, let's just look at days 0 to 36 here. So this is the entire sampling period. And comparing used versus nest habitat, the asterisks in the highlighted here, so average DBH in basal area, we found in our mixed effects modeling to be important. The 85% confidence interval didn't overlap 0. Fledglings were using areas with smaller average DBH than nests, so 54 to 42, you can see that's a difference. And so these ones I've highlighted were the ones I deemed to be important using the mixed effects modeling. And that included not understory, but mid-story, distance to gap, distance to water, basal area, and average DBH. So all of those were, quote, significantly different than the nest habitat. And so that was using these mixed models. Anyway, let me show you an example. Yeah, so we included brood ID as a random effect in these mixed models to soak up that variation. We didn't care about variation by brood. We were interested in looking at individual habitat selection. And we did that using GLMER, the function. But here are the results of our Wilcox tests. So these are the Mann-Whitney tests. And here you can see the Mann-Whitney test is another name for the two-sample Wilcoxon test. So here, average DBH between fledglings and nests. You see this tiny p-value indicating that there is a difference between the two distributions. And here, that's what we got with the linear mixed effect modeling, so that's good. And maximum DBH, fairly highly correlated with average DBH, about 60% correlated, but we looked at it anyway. It was not significantly different. So maximum DBH may be important for nesting habitat. They might choose those biggest trees, but for fledgling habitat, yeah, I don't know. We probably could have chosen to not include that, but I decided to look at it anyway here. Basal area, almost significant at the 0.05 alpha level, so we got 0.057. And let's see what we had. Basal area was included, if you remember, in the top habitat selection model, and it was also included as being different from nest habitat. So if we were using this Mann-Whitney test, I guess it would depend on our alpha level, and again, our sample size wasn't huge. We only tracked 21 birds. Our goal was 80, but it was very difficult to capture them. So again, 85% confidence interval, how informative is that? Choosing a p-value is sort of arbitrary. A 0.057%, maybe they're is something going on there. Basal area, maybe it's not quite as important or as different as average DBH. But if you look at the means here, the nesting habitat 18.7 plus or minus 2.4, that's the standard error. It does look different than the fledgling locations. So canopy height and sapling cover were not important using either method. Here we had high p-values, 0.45, 0.49, something. Shrub, same thing. Slope, beers. It's not how many beers they drank. It's beers aspect. It's a transformed aspect, but also not important or not different. I'm sorry. Understory, we didn't see a difference between fledgling and nesting habitat. Midstory was. Look at that low p-value. And let's close that. Yeah. Mid-story was also different using the mixed modeling, and distance to water was different using mixed modeling. Let's see. Also different using this analysis. So we did run a bunch of tests here, there's 9 of them. So if we were looking at these strictly these Wilcox tests, then maybe we would want to account for the fact that we did so many tests. And you could do that with Bonferroni corrections or other methods. But again, because of our small sample size, I'm not using Bonferroni corrections. You could imagine that would lead to fewer significant differences. So overall, though, this other alternative non-parametric method does generally give me the same results as my mixed modeling efforts, so that is comforting. And anyway, thank you for your attention, and once again, thank you to all my collaborators and field technicians and sources of funding for this project. And have a great day or evening, everybody. Thank you.